You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Small batch delivery is the practice of shaping increments into thin, end-to-end slices that can be validated quickly, reversed safely, and used to generate evidence of value. The orientation emphasizes that thin slices are the safest and fastest path to delivering outcomes because they reduce risk, accelerate learning, and stabilize flow. Unlike large releases that delay feedback until everything is integrated, small batches surface results early, providing both user-facing impact and system-level assurance. They also prevent long periods of uncertainty where effort accumulates without proof of benefit. By reducing batch size, organizations improve adaptability as each slice provides data that informs the next step. Small batches turn delivery into a continuous cycle of hypothesis, observation, and refinement, ensuring that outcomes are validated in real time rather than assumed in hindsight. This approach balances speed with safety, making agility both reliable and responsible. The batch size rationale links smaller work directly to shorter cycle times and lower variability. When increments are thin, they pass through pipelines faster, providing outcomes and signals quickly. This reduces the window during which assumptions remain untested and prevents surprises from snowballing. Smaller batches also localize defects. If something goes wrong, the scope of impact is limited, and the cause is easier to trace. By contrast, large releases accumulate uncertainty, amplifying variability and making prediction unreliable. For example, a thin slice that introduces only one new workflow can be tested, validated, and reversed far more predictably than a release bundling 10 workflows together. Shorter cycles also provide more data points for forecasting, stabilizing throughput, and improving planning confidence. The rationale is simple. Smaller units of change move faster, break less often, and provide more reliable feedback for decisions. Vertical slice preference reinforces that small batches must deliver observable behavior rather than internal fragments. A vertical slice spans interface, logic, and data, producing a result that users can experience or systems can verify. This stands in contrast to horizontal slices, such as only database schema changes, that postpone validation until all layers converge. For example, instead of building an API endpoint now and the front end later, a vertical slice delivers a working add-to-cart function that demonstrates the full workflow. Vertical slices reduce coupling risks and ensure that feedback reflects the whole experience, not just a partial view. They also validate integration points early, avoiding the painful surprises that emerge when disconnected layers are finally assembled. By shipping vertical slices, teams ensure that small batches are meaningful experiments in value, not just technical scaffolding hidden from users. The coherence test ensures that each slice is small, yet still complete enough to be valuable and testable. A coherent slice has a clear goal, defined acceptance criteria, and outcome signals that make success knowable within the time box. For example, enable self-service password reset via email link is coherent. It solves a clear problem, has verifiable acceptance, and provides measurable outcomes like reduced support tickets. By contrast, design new reset template lacks coherence because it cannot prove value until paired with other work. The coherence test prevents decomposition from drifting into fragments that may be small but do not deliver outcomes. It ensures that each slice is an independent unit of learning. This discipline anchors right sizing to impact, reinforcing that size is not the only criterion. Clarity, measurability, and observable benefit matter just as much. Work-in-process limits amplify the power of small batches by protecting focus and finish rates. Even when slices are thin, starting too many at once undermines predictability as attention is divided and context switching increases. WIP limits cap the number of concurrent starts, ensuring that teams swarm to finish work before pulling more. For example, a team may set a limit of 3 items in development, prioritizing completion over expansion. This practice reduces cycle times further since fewer items linger half-done. It also improves quality, as attention is concentrated on resolving blockers and meeting acceptance criteria. WIP limits make small batch delivery sustainable, preventing the illusion of speed that comes from starting widely but finishing slowly. They reinforce the mantra that flow is measured not by how much begins, but by how much reaches done. Continuous integration and continuous delivery pipelines make small batches possible by automating build, test, and promotion steps. Manual processes introduce friction that makes frequent releases impractical. With CI/CD, every commit triggers automated validation, shrinking feedback loops to minutes. For example, a code change introducing a new workflow passes unit tests, integration checks, and deployment pipelines without waiting for human intervention. Automation ensures that small increments can move safely at speed, reinforcing the discipline of thin slicing. It also reduces the risk of defects, since problems are detected quickly in small changes rather than buried in massive merges. CI/CD turns delivery into a flow of validated increments, each producing observable results. By automating the path to production, organizations unlock the full potential of small batch delivery, marrying rapid feedback with reliability. Feature toggles give teams fine-grained control over exposure, decoupling deploy from release. With toggles, increments can be deployed into production, but activated only for specific users, scenarios, or time windows. This makes experiments safe, enabling targeted A/B comparisons or staged adoption. For example, a toggle might release a new recommendation engine to 5% of users, allowing signal collection without committing fully. If signals are negative, the toggle rolls back quickly without needing to revert deployments. This control mechanism makes small batches even safer, as exposure is reversible and evidence emerges from real-world use. Feature toggles embody the principle that change should be incremental, testable, and recoverable, making delivery less risky and more adaptive. Canary and ring strategies extend the philosophy of controlled exposure by gradually rolling out increments to cohorts. A canary release introduces changes to a small initial group, while ring releases expand adoption step by step, such as internal teams first, then regional subsets, and finally all users. This staged approach improves signal quality while limiting user impact during early exposure. For example, a new checkout flow might first be tested with employees before being released to 10% of customers in one region. Observed metrics then guide whether to expand or pause. These strategies allow thin slices to generate high-quality feedback under real conditions while protecting the majority from untested risks. By structuring exposure, canaries and rings add another layer of safety to small batch delivery. Observability per slice is essential for confirming outcomes and detecting issues quickly. Each slice must include events, logs, and dashboards that verify behavior as soon as it is exposed. Without observability, small increments provide little value, since results cannot be measured or anomalies caught early. For example, a login feature might log error counts, response times, and user flows, feeding dashboards that alert if thresholds are exceeded. Observability ensures that decisions about next steps are evidence-driven, not speculative. It also supports rapid rollback by providing precise signals about what went wrong. Embedding observability in every slice ensures that small batches not only deliver functionality, but also provide the data needed to validate, learn, and adapt responsibly. Rollback readiness reinforces that small batches remain safe by treating reversals as routine rather than exceptional. Every slice should have pre-planned steps and criteria for rollback if signals go negative. For example, if error rates exceed a set threshold, rollback is triggered automatically. By normalizing reversibility, small batches reduce fear of failure, enabling teams to release confidently. Rollback readiness prevents minor issues from cascading into large incidents, since containment is immediate. It also builds trust with stakeholders, who know that increments can be withdrawn without drama. Making rollback a standard practice, not a last resort, aligns with the philosophy that every change is a testable hypothesis. This discipline strengthens resilience, making delivery safer and more reliable. Dependency decoupling allows small batches to progress even when external systems or partners are not ready. Stubs, adapters, and contract tests Simulate interfaces, ensuring that increments can move forward while dependencies mature. For example, a payment system integration might proceed using a stub that mimics responses until the live service is stable. Contract tests confirm that eventual integration will be seamless. This approach keeps flow moving and reduces idle time caused by external delays. It also surfaces risks earlier by validating assumptions about dependencies. By decoupling dependencies, small batches preserve momentum, proving that agility means adapting scope and sequencing rather than waiting passively for conditions to align. Compliance evidence accrual integrates regulatory and audit requirements into each slice. Instead of scrambling at the end of a release cycle to produce documentation, compliance artifacts are captured incrementally as work is delivered. For example, a new feature might log approval records, traceability links, and retention notes at the point of completion. By embedding compliance into each slice, organizations avoid last-minute document scrambles and demonstrate continuous accountability. This practice aligns agility with governance, showing that speed and trust can coexist. Compliance evidence accrual reinforces that every increment must be releasable not only technically but also legally and ethically, protecting organizations from risk while sustaining delivery tempo. Risk-first ordering strengthens learning by prioritizing high uncertainty or high-exposure elements early. Instead of postponing difficult tasks, teams tackle them upfront as thin slices, converting speculation into evidence. For example, if a dependency on an external API poses risk, the first slice may test that integration in a minimal way. By addressing risks early, organizations prevent surprises late in the cycle when costs are higher. Risk-first ordering ensures that learning occurs when it is most valuable, and corrective action remains affordable. It also builds stakeholder confidence, as uncertainty is surfaced and addressed proactively. This strategy makes small batch delivery not just efficient, but also resilient, turning potential pitfalls into manageable experiments. Remote-friendly practices make small batch planning and sequencing inclusive for distributed teams. Written pre-reads allow members to review slice options asynchronously, while concise sessions focus on decision-making rather than prolonged debate. Digital boards and collaborative tools ensure that slicing and ordering are transparent across time zones. For example, decomposition proposals may circulate for review before refinement meetings, saving time and enabling broader participation. This approach prevents ceremony overload while preserving clarity. Remote-friendly practices reinforce that small batch delivery must be equitable, ensuring all contributors have equal access to decisions. Inclusivity strengthens alignment, making right-sizing a shared discipline rather than the privilege of those co-located. Anti-pattern alerts remind teams what undermines small batch delivery. Big Bang releases delay validation and magnify risk, defeating the purpose of slicing. Just one more thing, scope creep bloats increments, making them too large to test or finish predictably. Quality shortcuts disguised as speed create rework later, eroding trust and slowing flow. These pitfalls are tempting under pressure but always costly in the long term. By recognizing and calling out these patterns, organizations preserve the integrity of small batch practices. Anti-pattern awareness reinforces that the discipline of slicing exists to protect predictability, safety, and learning. Avoiding shortcuts ensures that small batch delivery continues to deliver on its promise of safer, faster, validated outcomes. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Decomposition patterns provide structured options for shaping small batches without losing focus on outcomes. One well-known framework is SPIDR: spikes, paths, interfaces, data, and rules. Spikes are thin, exploratory increments that test uncertainty without committing to full production code. Paths reflect workflow steps or user journeys that can be sliced individually. Interfaces focus on specific channels such as mobile, web, or API. Data slices validate conditions, ranges, or edge cases incrementally. Rules handle variations in business logic, starting with the happy path before layering exceptions. By applying SPIDR, teams avoid ad hoc slicing that produces fragments with no measurable impact. Instead, each slice remains outcome-oriented, structured around a type of value or risk. Decomposition patterns give teams a toolbox for right-sizing thoughtfully, reinforcing discipline, and ensuring that increments deliver clear, testable outcomes that move strategy forward. Selection heuristics guide teams in choosing which slices to prioritize. Heuristics favor slices that are coherent, minimally coupled, and capable of generating high learning relative to their effort and risk. For example, when multiple decomposition options are available, the heuristic may prioritize a slice that validates an integration assumption over one that delivers a minor cosmetic change. Minimizing coupling ensures that a slice can move independently without being blocked by upstream or downstream dependencies. Prioritizing high learning value ensures that even small slices generate evidence to inform decisions. Heuristics are not rigid rules but guidelines that discipline choice. They balance strategic priorities with operational feasibility, ensuring that small batches are selected for their impact on outcomes, not just their convenience. By using selection heuristics, teams keep increments thin, yet strategically potent. Backlog ordering translates decomposition and heuristics into sequencing. Thin slices that directly advance the increment goal are prioritized, while optional could items are deferred until capacity remains. For example, if the increment goal is to reduce checkout abandonment, backlog ordering will prioritize slices such as simplify form fields and add progress indicator before deferring less essential features like cosmetic theming. Ordering by outcome relevance prevents energy from scattering into low-value slices that dilute focus. It also communicates clearly to stakeholders what the team will tackle first and why. Ordering creates transparency, showing how backlog items connect to the overarching goal. By curating slices in a disciplined sequence, backlog ordering ensures that the most valuable outcomes are validated early, while still leaving room for additional enhancements if capacity permits. Cycle time percentiles and age and stage alerts provide diagnostic tools for detecting when small batches are drifting into oversized increments. Tracking how long slices typically take to complete and identifying items aging in place highlights where decomposition may have failed. For instance, if 90% of slices usually finish in under 5 days but one remains open for 20, it likely needs further splitting or refocusing. Percentiles provide a realistic picture of flow variability, while age alerts highlight bottlenecks before predictability collapses. These signals enable proactive action rather than waiting for delayed outcomes. By monitoring cycle times with nuance, teams ensure that small batch delivery remains disciplined. This approach reinforces predictability, making increments both thin and timely. Cycle time awareness becomes a feedback mechanism for refining the quality of decomposition itself. Batch size metrics extend measurement by tracking the distribution of slice sizes and their corresponding lead time trends. Over time, organizations can assess whether right sizing is actually improving system behavior. For example, a healthy distribution might show most increments falling into a small or medium range, with very few large outliers. Lead time trends can then confirm whether smaller increments correlate with faster, more predictable delivery. Without such metrics, teams may believe they are working in small batches while hidden bloat persists. By measuring distribution explicitly, organizations gain evidence of whether their decomposition discipline is holding. Batch size metrics also support coaching and improvement, highlighting where additional refinement or training may be needed. This measurement closes the loop between practice and performance, validating that small batch delivery is working as intended. Environment and data readiness ensure that thin slices are safe and trustworthy when shipped. Test environments must mirror production closely enough to catch issues before exposure. Data used in validation must be ethical, respecting privacy while still providing realistic coverage. Repeatability is also essential. Slices must be tested consistently under comparable conditions to ensure results are credible. For example, a feature tested with synthetic but representative data can validate edge cases without exposing sensitive information. Without readiness, Small batches risk producing misleading results or creating compliance exposure. By preparing environments and data with discipline, organizations ensure that every slice is both safe to release and reliable as evidence. This preparation makes small batch delivery trustworthy, preventing fragility that undermines agility. Operability tasks must travel with every slice to ensure reliability after release. These include adding alerts, runbooks, monitoring dashboards, and readiness checks. For example, a new workflow might include a runbook for operational teams and alerts for error conditions. Without these, slices may function at first but strain support and reliability as they scale. Embedding operability into every increment prevents gaps where user satisfaction rises but operational burden explodes. It also reduces surprises by making reliability part of the definition of done. Operability tasks align small batch delivery with long-term resilience, ensuring that speed does not sacrifice maintainability. By treating operability as inseparable from functionality, organizations preserve trust and reduce total cost of ownership. Data migration slicing applies small batch thinking to one of the riskiest delivery activities: schema changes and cutovers. Instead of one large migration, work is divided into reversible steps, such as creating new schema, backfilling data gradually, and switching over with verification checkpoints. Each step is validated independently with clear rollback criteria. For example, migrating a customer database might start with duplicating schema, then moving subsets of users while monitoring for integrity issues. This reduces blast radius and ensures that failures can be corrected without catastrophic impact. Data migration slicing demonstrates that even large, high-risk activities can benefit from thin, testable increments. It makes critical changes safer and more predictable, aligning migration with the principles of small batch delivery. Security and performance slices elevate risk areas into first-class increments rather than late add-ons. By dedicating slices specifically to verifying security controls or performance thresholds, organizations surface risks earlier and reduce exposure. For example, a slice might implement load testing for a new API under expected traffic conditions, or another might verify encryption compliance for sensitive data. These slices provide targeted evidence of resilience, ensuring that small batches are not only functional but also trustworthy under stress. Treating risk slices as equal to feature slices prevents the pattern of discovering vulnerabilities or bottlenecks too late. It demonstrates that value includes safety and reliability, not just visible functionality. Security and performance slices protect outcomes from fragility and ensure compliance with trust expectations. Stakeholder expectation management is critical when shifting to small batch delivery. Stakeholders accustomed to big releases may interpret thin slices as underscoped or incomplete. Teams must reframe the narrative. Small batches represent faster learning and safer change, not less delivery. For example, stakeholders may be shown that a vertical slice of checkout validation provides immediate evidence about abandonment reduction, even if cosmetic polish comes later. By managing expectations transparently, teams build trust in the incremental model. Communication emphasizes the benefits: earlier feedback, reduced risk, and clearer attribution of outcomes. Stakeholder education ensures that thin slices are celebrated for their learning and value, not dismissed as fragments. This reframing makes small batch delivery sustainable politically as well as technically. Vendor adaptation extends small batch practices into external relationships. Vendors must align deliverables, compatibility guarantees, and review cadences with incremental exposure. For example, a partner providing an external API must support contract testing and staged rollout to fit the internal delivery rhythm. Without adaptation, vendors may become bottlenecks, insisting on large deliverables that undermine agility. By negotiating incremental commitments and shared testing protocols, organizations spread the benefits of small batches across boundaries. Vendor adaptation also builds shared accountability as external dependencies evolve in sync with internal slices. It turns delivery into an ecosystem practice rather than a local one, ensuring that agility is not constrained by external inertia. Recomposition and cleanup are necessary once learning stabilizes. Temporary scaffolding such as feature flags, stubs, and test adapters enable small batch delivery but must eventually be retired. If left in place, they clutter code bases, obscure logic, and increase maintenance costs. For example, once a feature flag has been fully rolled out, it should be removed, consolidating behavior into a clean baseline. Recomposition integrates validated increments into a coherent whole, preserving health while retaining agility. Cleanup ensures that small batches do not accumulate into technical debt. This practice demonstrates that agility is not just about moving quickly, but also about maintaining clarity and long-term sustainability. Recomposition keeps the system lean and reliable, reinforcing the discipline of incremental delivery. Knowledge capture ensures that lessons from small batch delivery accumulate into organizational memory. Each successful slice can be documented as an example, while challenges become cautionary templates. For instance, a team may record how decomposing a migration into reversible steps avoided downtime, adding it to a pattern library. Future teams then draw on these examples to accelerate decomposition decisions. Knowledge capture raises maturity across the organization, turning isolated wins into collective capability. It also prevents repeating mistakes by making pitfalls visible. By curating a pattern library of thin slices, organizations institutionalize right-sizing, reducing friction, and increasing consistency. Knowledge capture ensures that small batch practices improve continuously rather than restarting from scratch each cycle. Success evidence confirms whether small batch delivery achieved its promise. Indicators include shorter feedback loops, steadier throughput, fewer escape defects, and clearer attribution of outcomes. For example, stakeholders may note that decision-making accelerated because slices generated reliable data faster. Quality metrics may show fewer defects reaching production because changes were smaller and easier to validate. Attribution improves because outcomes can be tied directly to specific slices, clarifying cause and effect. These results validate that small batch delivery is not just theory but a practical improvement in flow and value realization. Success evidence reassures stakeholders that the discipline of slicing produces measurable gains. It closes the loop, proving that smaller, testable increments truly deliver safer, faster, and more accountable outcomes. Small batch synthesis highlights the mechanics that make this discipline successful: vertical thin slices, automation through CI/CD, observability at every step, and reversible exposure through toggles and staged rollouts. Structured decomposition patterns provide options, while cycle time monitoring and batch size metrics maintain discipline. Operability, security, and compliance are carried with each slice, ensuring reliability and trustworthiness. Vendor adaptation and stakeholder expectation management extend agility beyond the team to the broader ecosystem. Cleanup and knowledge capture preserves sustainability and maturity. The synthesis is clear. Small batch delivery accelerates value validation, reduces risk, and stabilizes flow. By committing to disciplined slicing and evidence-driven practices, organizations transform delivery into a safer, faster, and more trustworthy engine of continuous learning and improvement. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.